In this lesson, I'll show you how to find the general formula for a Maclaurin series. This is question 3 in the series. The question reads, find the Maclaurin series for f of x is equal to sine x. Now remember, the Maclaurin series expansion looks like this, and the general formula for a Maclaurin series looks like the following. Now we want to modify this so that it is for the function sine x. To do this successfully, you want to start by creating a table of derivatives of the function which you will evaluate at x is equal to 0. And that's the main difference between the Maclaurin series and the Taylor series. That in the Maclaurin series, you evaluate the function at 0, whereas in the Taylor series, it's something else, and you have x minus whatever that value is. So let's go ahead and create that table. My first column will represent n, which is the number of derivatives. So 0 represents the function not being derived, n at 1 represents the first derivative, n at 2 represents the second. And it turns out that to find the general formula for this function, you need at least 5 derivatives. So I'm going to write down 3, 4, and then 5. In my next column, I'll set f superscript n, where this n represents the degree of the derivative, at x. And my final column will be f superscript n, where x is equal to 0. When n is equal to 0, we just use the function the way it is, without taking its derivative. The first derivative of sine is equal to cosine. The second derivative is negative sine x. The third derivative is negative cosine x. Then we get back to sine. So after the fourth derivative, you go back to your original function, sine x. There's no need to go to the fifth one because it will just repeat the process. So I take this back. I don't need to find the fifth derivative. Now I'll substitute 0 into sine, and I remember that sine looks like this, where it starts off at 0 and 0, makes its way up to its maximum, minimum, and then back. So sine at 0 is equal to 0. Cosine at 0, remember cosine looks like this. Cosine at 0 is equal to 1. Negative sine at 0 is still 0. Negative cosine at 0 is negative 1. And then we are back to 0. So we have to create a general formula for this pattern. And whatever that general formula is, it will represent the top part of this infinite series. It will represent this part. Now just to give you an idea of what this expansion looks like, remember the Maclaurin expansion looks like this. Our first term would equal to 0 plus our first derivative at 0 times x plus our second derivative at 0, which was 0, and this whole term becomes 0, plus our third derivative at 0, which is negative 1, times x to the power of 3 over 3 factorial, and so on. Remember, this right here represents the expansion. We're looking for the general formula. Now, one thing that's interesting about these terms that I've shown you, you can cancel these out, you don't need to include them, is that all the exponents are odd. This is 1, this is 3. X to the power of 4, you would have 0 here, so that would go away. Then you would have x to the power of 5 at 5 factorial, and the number in front of x to the power of 5 would be positive 1. Now, since all of our x's have odd exponents, the way you represent that is you write down x to the power of 2n plus 1. This is only for odd exponents. For even exponents, you would write down x to the power of 2n only. That being said, this part right here will be x to the power of 2n plus 1. And n over here will be 2n plus 1 as well. So let's go ahead and write that down. We have the sum, where n is equal to 0, x to the power of 2n plus 1, and at the bottom we have 2n plus 1 factorial. Now we have to find a way to represent x, and then the next term, which is negative. This one was positive, then negative, and then it's positive again. To represent a pattern where it goes from being positive to negative and then positive, you use negative 1 to the power of n. And you can test that. If I substitute 0 into n, my first term, we end up with negative 1 to the power of 0. Anything to the power of 0 is 1. And that's the case here. if I substitute n is equal to 1 for my next term, I end up with negative 1 to the power of 1. That's negative 1. And then my subsequent term is positive. Negative 1 to the power of 2 makes it positive, and so on. So I'll write down negative 1 to the power of n, which represents this part. Therefore, our general formula for sine x is equal to what's written in green. And there you have it. That is how to find the general formula for a Maclaurin series.